Hey everyone. In this video, we'll be learning about the power rule in calculus. Now, the power rule is a basic rule of differentiation. It's used to differentiate functions of the form x to the power of n. And it states that the derivative of x to the power of n is equal to n times x to the power of n minus 1. So essentially, we're subtracting 1 from the original exponent with the original function, and we're leaving the old exponent as the new coefficient of the derived function. Let's do a couple of practice problems using the power rule. The first question we have is a function that is equal to 6x cubed minus 9x plus 4. I'll do the first one with you guys, and for the rest, you can try yourselves first. So with polynomial functions, the way we derive them is we treat each term separately. Let's first apply the power rule on the first term, 6x cubed. The first thing we do is drop down the 3, because 3 is our exponent on the first term, as seen highlighted in green. We then multiply this by 6, our old coefficient, times x to the power of 3 minus 1, because we want to subtract 1 from the exponent, as per our formula. Now let's work out the second term. Here, x is to the power of 1. So what that means is we drop down 1 times our old coefficient of 9 times x to the power of 1 minus 1. 1 minus 1, that's 0, which means that the x term gets cancelled out because anything to the power of 0 is 1. Now we have a constant term. What do we do with the constant term? Well, let's think about this. The constant term has an x power of 0. So 0 minus 1 is negative 1. But we're still dropping the 0 down. So what that would look like is 0, which is our coefficient, times 4 times x to the 0 minus 1. Now, you'll notice that it doesn't even matter what we have in the power here, because we're multiplying that by 0. So automatically this term gets cancelled out because we're dropping the 0 down. So what that means is that 4x to the power of 0 is going to be cancelled out in our derivative because we're multiplying that by 0. So we now know that constant terms get cancelled out using the power rule. Here, 1 minus 1 is x to the power of 0, so that gets cancelled out. What are we left with? We're left with the derivative of f of x is equal to 18x squared minus 9. Let's move on. Here's our second question. Feel free to pause your viewer and try this one out yourselves. Alright, like we did before, let's treat each term separately. In the first one, we drop down the exponent, multiply that by 2, our coefficient, times t to the power of 4 minus 1, because we have to subtract 1 from our old exponent. For the second term, we drop down the 2, multiply that by our old coefficient, times t to the power of 2 minus 1. For the third term, well, t is already to the power of 1, so 1 minus 1 is 0. We know that from the previous question, so it's just 13. Now, if you simplify this, we get 8, 4 times 2 is 8, times t to the power of 3, minus 20 times t to the power of 1, which is just t, minus 13. Let's try out the third question. Again, pause your viewer and see if you can do this one. Okay, this one's a little bit of a tricky one because we have some negative exponents, but don't worry, they work the exact same way as if we had positive exponents. So the derivative of this function, if we treated each term separately, is negative 4. Again, we're dropping down the coefficient, times y, the power of negative 4 minus 1. We still subtract 1 from the exponent. Subtract this by negative 3, we drop down the exponent, times 9 times y to the power of negative 3 minus 1. Now we add negative 2, drop down the exponent, times 8 times y to the power of negative 2 minus 1. And as we saw before, constants gets cancelled out by the power rule. So we don't have to worry about that. Now, let's simplify this. Here, we have negative 4y to the power of negative 5. Plus, because two negatives become a positive, 27y to the power of negative 4 minus 16y to the power of negative 3. Now, here's a quick tip. You know that negative powers are really just positive powers, but the reciprocal positive powers. So what this function could also look like alternatively is we have negative 4 over y to the power of 5. This is equivalent to this. Plus 27 y to the power of 4 minus 16 over y to the power of 3. So if you look at it this way, negative and positive powers are the same under the power rule. Next question. This one deals with square roots. See if you can figure this one out. Now this question is quite tricky because you need to recognize that the square root of x is equal to x to the power of 1 over 2. That means we can rewrite this whole function as x to the power of 1 over 2 plus 8 times x to the power of 1 over 3 minus 2 times x to the power of 1 over 4. Now we can use the power rule to differentiate this. So the derivative of y is equal to half x, because we're dropping down the coefficient, times x to the power of half minus 1 plus 1/3 times 8 x to the power of 1/3 minus 1 minus 1/4, dropping down the coefficient, times 2 times x to the power of 1 over 4 minus 1. Okay, cool. Now what do? We simplify. The derivative of y is equal to half x to the power of negative half plus 8 over 3x, sorry, to the power of negative 2/3 minus, this is 1 over 2x to the power of negative 3/4. Cool. And just because it's getting a little bit messy, this is our final answer. Our last question today. See if you can figure this one out. So here with this one, we're actually doing the negative exponent question. I think that was question 3 in reverse. Here we can rewrite this function as f of t is equal to t, or I should say 4t to the power of negative 1 minus, this is 1 over 6t to the power of negative 3, because 3 is in the denominator, plus 8 times t to the power of negative 5. So it's important that we're able to make this connection. Now we can differentiate this with the power rule. I think you guys should be good at this by now. So negative 1 times 4 times t times to the power of negative 1 minus 1, subtracted by negative 3. Make sure you don't get your signs mixed up here. There's a lot of negatives. Times 1 over 6 times t to the power of negative 3 minus 1 negative 5 times 8 times t to the power of negative 5 minus 1. So you end up with negative 4 times t to the power of negative 2 plus 3, because two negatives make a positive, times 1 over 6. I can rewrite this as 1 over 2 times t to the power of negative 4 minus 40 t to the power of negative 6. And here is our final answer. If you guys thought that was helpful, please do subscribe and watch some of my other math tutorials, because it really helps me grow my channel and spread more math content to other students. I will see you in the next video.